This is a video on related rates. The question states, a bird is flying horizontally 40 feet above the ground at a rate of 20 feet per second towards the camera. How fast will the camera angle need to change when the bird is a distance of 50 feet from the camera? So the first thing we should do is sketch a picture. So here's my bird over here. We want to find out the camera angle. So I draw a little triangle where down here, this is the camera. And up here, this is where the bird is flying towards. The bird is flying horizontally. I'll call that distance x. This distance 40 doesn't change as a bird flies. On the other hand, this distance 50 does change as a bird is flying. So I'm going to give that a variable z. So now let's find out what we have. We're told that the bird is flying 20 feet per second towards the camera. That's the rate of change of x with respect to time. With this triangle, let's relate the angle theta and the distance x. And we could do that because the tangent of theta is always equal to the opposite x over the adjacent 40. So we get tangent theta equals x over 40. Now notice that the bird is flying 20 feet per second towards the camera. The bird is flying along this line segment, so that means that's how much x is changing. So we can say dx over dt equals negative 20. Notice as the bird is flying, x is getting smaller, and that's why the negative sign. The question is, how fast will the camera angle need to change? Well, the camera angle is theta, and a how fast question is t. So our question, or our goal, is what is d theta over dt? So now I'm going to introduce some derivatives. I'm going to implicitly differentiate tangent of theta equals x over 40. And I get d over dt of tangent of theta is equal to d over dt of x over 40. Now the derivative of the tangent is a secant squared. And since the variables don't match, I need to write secant squared of theta times d theta over dt. Similarly, the derivative of x over 40 is 1 over 40, but then I need to multiply by dx dt because the variables don't match. Now that I've taken the derivative, I can plug in my numbers. I know that the secant is equal to the hypotenuse, which is 50, divided by the adjacent, which is 40. We also know that dx dt is negative 20, so I get 50 over 40 squared d theta dt equals 1 over 40 times negative 20. And now we can just simplify this. 50 over 40 is 5/4. Square that, you get 25 over 16. And negative 20 over 40 is negative 1/2. So I get 25 over 16 d theta dt is equal to negative 1/2. So now just multiply by 16/25, and I arrive at my final answer, which is that d theta over dt is equal to negative 8 over 25, and if we like decimals, that's equal to negative 0.32. So we can conclude that the camera angle is decreasing at a rate of 0.32 radians per second. And I'm done with the problem.